Hey, everybody. I am so excited for this chat today with Broadcom, the global tech powerhouse that's in the news pretty much every day. Ram, how are you?
Good morning. Doing well, thank you.
Well,
How are you,
thanks for
Evan?
joining. And I've been looking forward to this so much. Started my career as an electrical engineer in 1992. Gosh, I feel old. So fast forward to this day, and there's so many innovations happening in silicon semiconductor software systems and beyond. But before that, maybe if you could introduce yourself and your team within Broadcom.
Yeah, my name is Ram Velaga. I run the switching and routing group in Broadcom. Soon, I would have been here in Broadcom for about 12 years. Prior to that, I was with a large networking company for about 12 years. So, pretty much the entirety of my career has been in switching and routing and networking. And we have in Broadcom a team of about 1,300 engineers, some in California, some in India, some in Israel, and a few in the Far East Asia. So that's about a quick overview of our team.
Oh, it's a fascinating mission. And Broadcom is so diverse and interesting as an organization. Of course, you're known for your M&A activity, and you joined Broadcom through Avago in 2015. Now, what was that journey like?
Yeah, actually, w- I came through Broadcom. The interesting part of the story here is Avago bought Broadcom, but kept the
Aha!
Broadcom
I had
name.
it backwards.
Yeah, yeah. So Avago bought Broadcom, but kept the Broadcom name because Broadcom is kind of a very very powerful brand, and really a lot of the technology leadership that was there inside of Broadcom. Now the interesting part was when Avago bought Broadcom. Avago was a less known company and
Mm,
of a smaller scale potentially in terms of revenues compared to what Broadcom was. And a lot of people were really concerned when the news came out that said, "Hey, headline. You hear rumor on Wall Street, Journal a day before something happens," and a lot of our team was, "What does this mean? Avago is not necessarily known for doing a lot of leading edge technology and so on and so forth. Does it mean there'll be lesser R&D investment and so on and so forth?" In reality, actually, what manifested itself in is Mr. Hocktan, who ran Avago then and Broadcom, now, is very focused on doing, few things and doing them extremely well.
mm,
Generally, there's a tendency within companies, which is there's a core competency that gets them to a certain amount of scale and growth, and after they achieve that, great growth and scale, then for continued ability to grow, they start investing in a lot of other side markets and technologies, which might not necessarily
mm,
pan out. But in an attempt to do that, because there's a lot of pressure from the public markets, and they end up starving the core businesses.
mm.
So what ends up happening is your core businesses that have a potential to grow are not fully, taken advantage of, and a lot of your side bets don't manifest themselves. And so Mr. Hawk it has a different approach, which is he looks at core businesses and say, look, there is a tremendous opportunity to continue to be leaders in this space. Let's invest in this, business, grow the business, and make sure we are industry leaders. And that's exactly what ended up happening to our team, which is, back in 2016, right after we got acquired, mostly what I heard from our competition and customers is, look, you guys are not going to be able to invest, you won't be able to innovate, so there's an opportunity for us to come and grow, take away share from you, and so on and so forth. But in reality, what's happened is over the period of the last 7 to 8 years, the size of our R&D investment actually grew almost 2.5 to 3x in size. We have
Wow.
the same number of people. Right? The interesting thing is we didn't necessarily grow the size of our team, but we have invested largely in the team. If you think about it, if you're
Mm,
if you're spending 2.5 to 3 times more if you have the same number of people, and 70% of the cost of running an engineering organization is people cost. Generally, what it means is that people are getting rewarded well. and you're hiring the best and the brightest talent, and you keep a lean organization, and you move very, very fast. So lo and behold, 8 years later, I would say we've been able to innovate faster than we've been able to innovate before, and we continue to have industry-leading products. We have some of the best talent in the industry, and we have very low, attrition rate. Generally in a technology industry where you probably have 8 to 10+% attrition, the attrition in our organization, specifically in my team, is less than about 2% a year, probably even closer to 1%.
Wow.
So I would say we're thankful for the acquisitions that have happened. We're thankful for Mr. Hoktan's focus on leadership of products, and more importantly, his focus on keeping a lean organization and rewarding the team well, but also expecting that the team delivers industry-leading products.
Industry-leading products, indeed. And let's dive right in, because we're hearing about AI all day, every day, everywhere, all at once, like the movie. Particularly with CES happening right now, but not so much about what's happening at layer 2 and layer 3 of the network that actually powers all of this cool AI innovation, devices, applications, etc. So, in the context of AI, tell us about innovation there at the Ethernet level, the Ethernet product solution level.
Yeah, I think, for most of us, we would say we weren't thinking much about, AI till, December of 2022, when, ChatGPT first unveiled itself, and everybody was kind of, really taken back by the power of what's possible then. So you look at this now, we've had a lot of time, to think about this problem, even just before, November of, 2022. AI is really a distributed computing problem. And the reason I say it's a distributed computing problem, is the fact that you can take any workload, like if you think about a large language model, you cannot fit a large language model onto a single GPU. You need many thousands, if not tens of thousands, and people are already talking about hundreds of thousands of GPUs working together so that they can train a large language model, right? So when you take one workload and it is distributed amongst a lot of different individual compute nodes, it's a distributed computing problem, right? One of the earlier manifestations of a distributed computing problem was, for example, when Google built their search engine about 20 years ago. The search engine, you could not do it on one CPU. They had rows and racks of CPUs, tens of thousands of those, hundreds of thousands of those, which filled up a data center. And the search engine actually ran on many of these machines, right? So it's very important to understand that machine learning is a distributed computing problem on steroids. That's very different than the whole idea of virtualization and cloud computing, right? Because if you think about what virtualization is, it says any one application cannot fully consume a CPU. So I'm going to virtualize the CPU and run multiple different applications. So generally in a cloud computing, you don't stress the network like you would do in a distributed computing problem. And a lot of these HPC workloads, even before you heard about MLAI, whether it is weather simulations, seismic simulations, or all of this work that happens in the HPC, they were all distributed computing problems. In a distributed computing problem, the network essentially connects all these compute nodes, and the network is the computer. And this is what Sun said, a long time ago, almost 20 to 25 years ago. I didn't understand it then when they said network is the computer. And today, I'm an absolute believer the network is the computer, because if the network doesn't work, any one GPU cannot get the work done. So with that as a backdrop, and once you actually realize that the network is the computer, and I would also give credit to, Mr. Jensen, a few years ago when they bought, Mellanox, because they kind of realized for the GPUs to scale, you need to essentially have the network, right? So all of this essentially points to the fact that you need a network. And how do you actually scale to these kinds of very, very large scale topologies? And our belief there, and it's already proven, that Ethernet is the solution, because Ethernet, if you think about it, it's already running in the large cloud platforms, and it's connecting hundreds of thousands of CPUs, if not many more. And then the exact same Ethernet technology can be used to connect a lot of these, GPUs together. So then you say, okay, you're going to connect a lot of these GPUs together, and you're going to connect tens of thousands of these GPUs, and each of these GPUs is going to require 200 gigs, 400 gigs of Ethernet coming out of it. Then how do you do it? So effectively, what you need to do is you need to have a network that's very scalable and actually is very, very economical and easy to build and plug and play, right? This is where I would actually say you have to democratize the network. If you're able to democratize the network, it's not a network that otherwise costs $1 million to build 128 ports of 100 gig, right? Actually, if you think about it, not long ago you would be spending a lot of money to build a network. So you need to democratize the network. Once you democratize the network, then you also democratize machine learning, right? So that's where I think it's not talked about, but Ethernet is fundamental to machine learning and AI because the network is the compute in a distributed computing problem.
Oh, wonderful insight there. And let's talk about Ethernet. I was just recently watching a talk with Bob Metcalf, the great creator, inventor, him and his team at Park of Ethernet. And gosh, how time flies from the 70s, huh? But, given all the innovation there and the openness of Ethernet, what's next from your perspective for Ethernet and the whole, gigantic ecosystem that's spawned from this amazing platform?
No, actually, a lot of credit to Mr. Metcalf. And today, just as a data point, there's about 600 million new Ethernet ports that get shipped every year.
Wow.
600 million Ethernet ports every new year. And I actually was just doing the math. Apparently, there's about 150, million, babies born every year. So you could literally have 4 Ethernet ports, one for each limb, hypothetically, for every baby born. And that is the scale of Ethernet, right? And the beauty of Ethernet, it's plug and play. The beauty of Ethernet is it's standards based, it's interoperable, and you could have a dozen vendors or more all bring their Ethernet products and make all of this, work together, right? Now, the beauty of Ethernet is also because of the scale and plug and play, and there's so much competition, in this space, the economics of Ethernet are unmatched, both in terms of the performance improvements and the reduction in price per gigabit of bandwidth delivered or power per gigabit of bandwidth, delivered. And to just kind of, highlight this a little bit more, about 10 years ago, if you went to buy, and you wanted to buy 128 ports of 100 gigabit Ethernet, right? 128 ports of 100 gigabit Ethernet, you would essentially get a system which was half rack in height.
Right.
It would cost about $1 million. Okay.
Wow.
And it would consume 20,000 watts of power. Okay. So half rack height, $1 million, and 20,000 watts of power. Okay. Today we have a device, this is called, Tomahawk 5. And this device is 512 ports of 100 gig. So I was talking about 128 ports. This is 4 times the bandwidth, right? 512. Okay. You're talking about $1 million. Today, you can buy a box that is based on this for, maybe a $20,000, around $20,000 plus or minus, depending on who you're buying it from, right? So, and then the power of this device is less than 1,000 watts. So think about it. In 10 years, you went from something that is 128 ports of 100 gig to 512 ports of 100 gig, $1 million down to $20,000 plus or minus, from 20,000 watts of power to less than 1,000 watts of power. So when people are worried about inflation, I would say at least it is not in the Ethernet world. Okay.
It's the ultimate deflation. Yes.
It is the ultimate deflation. And why? One, it's because the economies of scale on Ethernet, just the fact that you have 600 million ports and you have a lot of competition. The reason you have a lot of competition is it's open standards, everything is plug and play. So people are constantly kind of, innovating. And there's a very large ecosystem, built around this, right? So I'd like to kind of, remind everybody that what we take for granted for Ethernet today is the essence for everything connected. Whether you're at home, you're at work, you're driving around. It's the basically the highways on which everything that's possible today is happening. And I'm very thankful for Mr. Metcalf, and everybody else who contributed to it. Now you take
Yes.
that and say, yeah, sorry, Evan, go ahead.
No, please continue. I'm
Yeah,
intrigued.
you take that and say, okay, is the Ethernet that we have today great enough for where we want to go going forward as we connect a million, if not hundreds of thousands of GPUs and millions of GPUs, what else needs to happen? And that's when we said, hey, look, there's some enhancements that can happen to Ethernet. And as Ethernet has always been, you bring a collection of different, industry leaders to the table and talk about enhancements that need to happen to the Ethernet. So about a couple of years ago, we started this consortium called the Ultra Ethernet Consortium, entirely focused on being able to connect up to 1 million GPUs, each having at least a few hundreds of gigabits of bandwidth coming out of each of them, so that you can build very, very large clusters to run this and run and train these very large language models, right? Broadcom was one of the founders, along with, a host of other companies like Intel, AMD, Microsoft, Meta, and so on and so forth. So where we are today is in making those improvements to Ethernet so that it can scale with the lowest latency fabric that is possible in a way that it is interoperable, easy to manage, and extremely reliable. Because when you're running networks of this scale, what you don't want is a network that is flaky, right? So that's where Ethernet is headed, heads down, focused on it. The challenges that AI is going to keep throwing at the network. Ethernet is here already. 7 out of the 8 largest cloud providers in the world are already running their AI infrastructure based on Ethernet, and our goal is to continue to scale this going forward.
Wow, incredibly exciting, very interesting. So let's talk about the marketplace. This incredible growth, hypersonic growth, but change and disruption for everyone, including companies like Broadcom. How do you stay agile? How do you adapt to all of these new market requirements and continue kind of to stay ahead of the curve?
Yeah, one, I think agility to a certain extent is also a structure of your organization. The fact that our team has kind of pretty much been the same size of the team, 7, 8 years to go what it is now, allows us to keep a very lean organization, very flat. We don't have many layers of the organization. And what that means is the information in the organization flows very, very fast, and we are able to actually make decisions very fast. Doesn't necessarily mean all our decisions are right all the times, but when you make fast decisions and mobilize the organization, move quickly, even if it is an bad decision, you have a feedback loop that is just as fast, and you're able to course correct, right? And by virtue of the fact that you actually have a lean organization means you have your ears to the ground. You're constantly actually looking at what's happening around you. You're staying close to your customers and getting feedback from the customers. You get good feedback from the ecosystem, and you're able to move very quickly. So I think that's very, very fundamental, being able to move quickly in an organization that is lean and agile and is also paranoid. We always, remind ourselves the business that we have built over the last 10, 20 years could be easily lost in a span of 2, 3, 4 years if we are not in executing and not innovating, right? For us, we very strongly believe in execution. That's why if you actually look at our, last 10, years plus of execution, methodically, every 18 to 24 months, we double the bandwidth of our switches. As a matter of fact, it's interesting. Actually, somebody from outside can predict what our roadmap is because they'll say, hey, look, these guys came out with a chip in 2012, 2014, 2016, 2020, 2018, 2020, 2022, 2024. I can tell you what they're going to do in 2024 and 2026. And it's extremely important because when we are predictable, the ecosystem around us also is able to build and make sure that they are being very productive, building their products around us, and we're able to move very, very fast. So I would say being paranoid, lean organization, focus on execution is what we do.
Love that. It sounds so simple, but of course it's not. I'd love to hear leadership lessons or insights you might be able to share from leading such a dynamic business unit in Broadcom for so many years.
Just what we just touched on right now, right? One is being paranoid. Do not take your current
Mm,
state, for granted. And number two, book that I have read 20 years ago that I believe in every day is Innovator's Dilemma, which is the market that is yours today could very easily be disrupted by disruptive technology. So you always have to worry about being able to disrupt your own self, because if you worry about the margins that you have today, the products that you have today, and you're trying to defend them, you could be disrupted by something that you haven't thought about. So be willing to disrupt yourself. And number three, really focus on execution, and being able to execute is a function of having a team that's aligned, a lean organization, a very flat organization, and being very close to the customers as well as your entire ecosystem. I think those are my three.
great advice. You can't go wrong with that. Developers. Of course, it's always the focus. Um, Lots of new developers entering the market with Gen AI, lots of new OEM prospects for you. I can imagine Broadcom Silicon and all kinds of new platforms, as you can imagine better than I. Any advice to developers on getting started, going down the road of building in advanced layer 2, layer 3 connectivity? Any lessons learned from working with OEMs for so many years?
Yeah, what I would say is networking is plumbing that you only think of when it stops working, right? So when you go and especially talk to the next generation of potentially networking engineers that come in, people don't necessarily think about being in networking. They're thinking about how do I work at the application layer, how do I write some software, and so on and so forth. But I would say networking is such an exciting, piece, because if networking doesn't work, nothing's going to work, and there's so much
Mm,
innovation to be had in networking. So first, I would say please pay attention to networking, and there's a lot that could be done in networking, and the opportunity to actually innovate in networking is so interesting. As a matter of fact, when you look at companies, whether it's Google and so on and so forth, do you see the amount of white papers and papers or research papers that
mm,
are writing based on innovations that can happen networking? So first, I would say think about the art of what's possible. Don't take Ethernet for granted as it is today. People keep innovating in networking, so you should do that. And number two is obviously there's a lot of platforms that you can continue to grow on with regards to the silicon that's available, the operating system stacks that can be developed, the next generation of operating system stacks that could be developed. So if there's one message, is do not ignore networking. It's a great opportunity to be, and it's the essence of computing.
well, fantastic advice. So we're in the heat of 2024. I can't believe it, but here we are. Any trips, travel events coming up? You're going to be hitting the road soon, I imagine. Anything you might share?
Well, looking forward to MWC,
Hmm.
Barcelona, where I think we will get to hear a lot more from everybody else about what's happening in the area of ML AI in the context of networking.
Mm,
So I think that's next on next immediate trips.
fantastic. Well, I'll be there. Look forward to seeing you in person. And thanks so much for your time and the insights. I know you're extraordinarily busy. Much appreciated. And thanks everyone for watching. Reach out to Broadcom. They're all over social media with great content and white papers and news announcements. So catch them there. Thanks so much, Ram.
Thank you, Evan. Thanks for the opportunity. Have a good day.
Take care, everyone. Take care.
Bye.
Bye bye.
Thank you.